Good evening all. Now I would like to discuss about bridge rectifier. Okay, see here bridge rectifier essentially consisting of a step down transformer and 4 PN junction diodes and load resistance RL. Okay, across this load resistance output will be measured. Okay, now we will discuss about the operation of this bridge rectifier. Okay, see here during positive off cycle plus comes here and minus comes here, right? Here it is plus, here it is minus, right? Okay, when positive terminal is connected to D1 anode with respect to negative, then D1 is in forward bias. Positive terminal is connected to D4 cathode with respect to negative terminal, that means D4 is in reverse bias. Similarly, negative terminal is connected to D3 cathode with respect to positive terminal, then D3 is in forward bias. Negative terminal is connected to D2 anode, then it is in reverse bias. That means during positive off cycle, diode D1 and D3 are in forward bias, right? And diode D2 and D4 are in reverse bias. Okay, during positive off cycle, the diodes D1 D3 are in forward bias and the diodes D2 D4 are in reverse bias, right? When diodes are in forward bias, those two diodes will act as a closed switch, that means it acts as a short circuit. Okay, the reverse biased diodes will act as a open switch. Okay, when this will happen, the current is flowing through the source to load resistance RL2, right, from this short circuit path to, in this way current is flowing through the diode, right? If we apply KVL, this Vs will be applied across the load terminals. Okay, this is the output voltage, right? Then output voltage will be same as input voltage during positive off cycle. Okay, that is, you can observe here. Okay, you will get output voltage will be same as input voltage. Okay, in this case diode D1 and D3 both are in forward bias, these two are in conduction mode, right? That is about during positive off cycle. Okay, next operation 2, that is during negative off cycle. Okay, that means minus is comes here, plus is comes here, right? When negative terminal of the negative terminal of the transformer is connected to D1 anode with respect to positive terminal, then D1 is in reverse bias, right? Negative terminal is connected to D1 cathode with respect to positive terminal, then D4 is in forward bias. Similarly, positive terminal of the positive terminal of the transformer secondary is connected to D3 cathode, then it is in reverse bias. This positive terminal is connected to D2 anode, that is in forward bias. That means during negative off cycle, diode D1 and D3 are in reverse bias and diode D2 and D4 are in forward bias. Okay, the forward biased diodes are act as a short circuit or closed switch and the reverse biased diodes are act as a open circuit, right? Here supply terminals will be here minus, here plus. Okay, now the current will flow from higher potential to lower potential, right? That means in this way current is flowing. Okay, source positive to load resistance RL2, again source negative. Okay, that means phase to neutral. Actually in case of AC supply there is no polarities. For your understanding purpose I am giving polarities. That means during positive off cycle I am giving plus minus, that means that is phase neutral. During negative off cycle minus plus means it acts as a phase, it acts as a neutral, right? Now see here in operation 1 also current flowing through the load direction is in this way only, downwards. During operation 2 also this is the direction of current flowing through the load resistance RL, right? That means if supply terminals are changed also, there is no change in load current direction, then output voltage polarities will be same during operation 1, that means during positive off cycle as well as during negative off cycle, right? Same current direction, right? Positive off cycle as well as negative off cycle. Hence in case of operation 2 also we will get output voltage only in positive off cycle. Okay, hence output voltage will be present in positive off cycle only. Here input voltage will be changed but output voltage terminals cannot change, right? Then you will get output voltage in positive half only. Again this will be repeated. This is the output voltage waveform. This is the output current waveform. Okay, that is about the operation of the full wave bridge rectifier. Okay, what is the drawback of center tapped rectifier? The drawback of center tapped rectifier will be cost of the center tapped transformer is high. That will be overcome here, right? Next drawback will be peak inverse voltage will be 2 Vm, right? That drawback is overcome, or we will check now. Now see here, in this case, if I apply KVL here in this loop from transformer to this open circuit loop, what happened? The voltage across this diode will be Vm only. Suppose if I apply KVL here, output voltage will be same as input voltage. That means across diode contacts supply voltage only. Again, if I apply KVL here also, the voltage across the diode will be only supply voltage. That means, what is my peak inverse voltage? The amount of voltage, that is the amount of reverse voltage that can be bear by the diode, right? In any loop, the diode must and should bear only supply voltage. That the maximum voltage will be Vm, right? Then here the peak inverse voltage will be minus Vm. Okay, that drawback is overcome. Here I am not discussing average value, RMS value, form factor, peak factor, right? Everything will be same as center tapped rectifier. Efficiency is also same, but formulas are different. Now see, just observe here, efficiency formula will be efficiency neta is equals to PDC by PAC. Okay, PDC is equals to IDC square into RL, right? PAC is equals to IRMS square into, in previous case we will get RF plus RL, right? But here see here, at a time this diode is in conduction mode and this diode D1 and D3 are in conduction mode, right? That means IRMS, when we consider IRMS square current, okay, diode forward resistance, D1 forward resistance, D3 forward resistance, that means RF plus RF, we will get 2 into RF plus RL. Okay, this is the different term. But while simplification, in numerator we will get IDC square into RL. In denominator IRMS square into, here I can take RL as common, I can take outside, we will get 1 plus 2 into RF by RL. Okay, this value will be very less, hence I can neglect this value. Here RL and RL will be cancelled. If you simplify this equation, again you will get efficiency will be 81.2%. Okay, this is only the difference. That means only peak inverse voltage. Solving, the way of solving is different for efficiency, but you will get 81.2% of efficiency only. Okay, now most preferred rectifier is bridge rectifier. Okay, we are having half wave rectifier, center tapped rectifier and full wave rectifier, but most preferred rectifier will be full wave rectifier. Okay, I hope you have understood each and every concept, right? Thank you all.